Alright, we're gotomath.com, working some calculus problems. And let's go down here. This is part of a live chat box. If you got a question, type it in there, and if I'm online, I will probably try to help you out. This section here, we're in infinite limits, and this is the button you need to click on if you want to see this kind of problem. It says find all vertical asymptotes of the function. Now it says infinite limits, and we'll get to that when you push this button here, but right now we just need to talk about remembering how to find vertical asymptotes and what they are. Alright, so 2 over x minus 4, remember that we have f of x is equal to 2 over x minus 4. Alright, so to find vertical asymptotes, we're just going to sketch out a graph here. What we want to do here is for example, remember what a vertical asymptote is. If I put 4 in right here, let's say, right, this is where the graph does not cross this imaginary line, and that the graph goes up but never touches it, or comes down the line but never touches. It gets real close but never touches. All right. So vertical asymptote, when is the denominator 0? That's what we're interested in. That makes when the denominator is 0 and the numerator is a number other than 0, I should actually say. All right. When is this 0? So you just take the denominator, set it equal to 0, and solve for x. Well, what a coincidence. It turns out that x is equal to 4. And that would be right here. All right. So what does this graph actually look like? If I was to graph, let's say, for example, 1 over x, all right, it looks like, something that comes down like this, does that. Now I'm putting dotted lines here instead of solid ones because I don't want to get them confused. But this particular one here it's been shifted 4 units. Now, if I were to plug 0 in to this, we'd end up having negative 1/2. So in other words, it crosses. We know that the graph crosses right down here at negative 1/2. If I were to plug 0 into this thing, plug 0 in for x. All right, so we know it's crossing here. If I were to set, using a different color here, set this equal to 0 and solve for x in this problem, right? Is this thing actually crossing the x-axis? That's the question. Can you plug something into this and get 0 out? And the answer to that is no. So we know that the graph is not crossing the x-axis, right? It's not, but it is crossing here, which is interesting. So what could this graph possibly be doing here? I mean, I think it's probably going like this, coming down like that, and then doing something like that, as you can see. Okay, but this is infinite limits, so if I were to take the limit as x approaches 4 and I get closer and closer to 4, what's my y value going? It's going to negative infinity. And if I were to take the limit as x approaches 4 coming into the right, what's my y value doing? It's going to, it's gone, right? It's approaching positive infinity. All right, so that's what this section is all about. Even though we're talking about this vertical asymptote here, we're going to get to the limit, where finding the limit coming in from the left and coming in from the right at 4, and seeing which way that it goes. Now this graph, I want to mention from the previous section, definitely is not continuous, because we have a vertical asymptote, not continuous in the entire real number line. It's discontinuous at 4. All right, a little extra there.